Hey guys, welcome back. Let's dive in. Fractions and ratios, Series B. So today we're looking at multiplying and dividing. We did add and subtract yesterday, and let's jump in here. Now on this first problem, we're actually going to go over to this side. We're going to start over here. We know this is a multiply problem because it's got parentheses. I've been hitting on that in the videos and in class. These parentheses with that 3/4 set up right next to the parentheses tells us that these guys are multiplying. Multiplying happens to be the easiest thing to do when it comes to fractions. In terms of operations, this is the easiest one. We're allowed to go straight across when we multiply, and it is as simple as it sounds. 3 times 1, 3. 4 times 3, 12. And then notice we can reduce this. Okay, we talked about reducing as part of the add subtract video. We're looking at any kind of common factor in both of these guys. What divides into both a 3 and a 12? It turns out 3 can go into itself. 3 also goes into 12. 3 divided by 3 is 1. 12 divided by that 3 is 4. And now we've taken that common factor out. It's reduced down and it's 1/4. Okay? So multiplying, we can go straight across. Let's go back over to this side and compare that, and let's notice something. When you are multiplying, notice we just went through that problem over here on the right again, and we didn't have common denominators. We used fourths and we used thirds. And what we're saying with this problem is I want to know what, if I'm starting with 3/4, I'm basically saying I want 1/3 of the original amount, and that original amount was 3/4. So basically, if we thought about it in our head, this is the idea of what's going on. We have this original amount of 3/4, and then we say, let's color code it a little bit, make it easier. I want 1/3 of that original amount. So I'm just going to come down here, and I could divide each of those into thirds, and then I'm just taking one little piece out of each of those. And then if I combine all those little bits together, turns out when I'm done, all those little bits become exactly 1/4. Okay, so that's the idea here. My point is, there was only one fraction bar. We're only actually working with one amount, 3/4. And then we take a piece of that candy bar. We started with 3/4 of a candy bar, and we're told to take a portion of it. So there's only one candy bar to begin with, and it's not even a whole candy bar. And then we take away a partial piece, or a few small partial pieces, of that original candy bar, and then we just figure out how much we have. And that's it. So the denominators don't matter. They don't have to be the same. You can go straight across and multiply every time on any multiplication problem, and you don't have to worry about it being a common denominator. Now let's go back over to this side. This is what we just looked at yesterday. And notice this one does not have common denominators. It's the same problem, in fact. We just changed the operation. And here, we can't go straight across because this problem is saying we have 2 candy bars to begin with. 2 separate candy bars. And all the pieces are different size pieces. So there's no way to add those together until we deal with these different size pieces. We have to get all of this to be the same size chunks. They're all different size chunks right now, so that's where we need that common denominator. And we would multiply 4 times 3, because that's the quickest, easiest way. We want to find a common multiple of 4 and 3. In this case, that's 12. So we need that common denominator. Okay? So I just wanted to point that out. Multiplying is simple. We don't need a common denominator. We can go straight across. That's the right side over here. But with addition, we do need that common denominator. So you've got to work and take that extra step. You've got to see that piece. Okay? I very often see kids not understanding that difference, and that's important. All right, let's move on. too far forward. Okay, multiplying fractions and whole numbers. Multiplying fractions is so easy. Let's look at what is some of the challenge involved, and it might be like this. 6 times 1/3. How do we do that? I bet you guys are remembering back to grade school. Any whole number can be made into a fraction by putting it over 1. Okay? And that's always the case. It's always equivalent. And if you feel comfortable doing it that way, you can keep doing it that way. There's nothing wrong with it. I just want to show you the shortcut to that. So right here we've got our multiplication. Now we can go straight across. 6 times 1, they're both on top. 1 times 3 for both the denominators. And then if we reduce that, remember all fractions are also a division problem. So there's 2 ways to look at it. You could take out any of those common factors. 3 divides into both. 6 divided by 3 is 2. 3 divided by 3 is 1. Anything over 1 is just the number. So you can look at it that way, and we're done at 2. Or you can just recognize, and some of you probably already did, 6 over 3, you can always look at a fraction as division. So it's just 6 divided by 3. Divide the bottom into the top. 3 will go into 6 twice, and that's another way to get to the answer. Let me show you a shortcut for that problem. Since any number times 1 is always going to be that number, you're really just going to end up moving whatever's on the bottom of the fraction to the answer in the denominator. That's always going to happen. So we could just shortcut. The only thing that really needs to happen in this problem is multiplying the whole number to the top of the fraction. That's all you need. And then you could just copy the denominator over to the answer. So let's show you what I'm talking about. Right here, 12 times 3, 36. And you can just copy over the denominator, and we're done. And if anybody's unsure, think about it this way. We could put the 12 over 1, because that's technically what's going on. And then what's 1 times 4? It's 4. And if that makes you feel better about it, by all means. But I think a lot of you are like me. You like the shortcut once you understand it, because that saves you time when you're working. So if you understand it, by all means, you can just start multiplying any whole number straight to the top of any fraction. That's all the work that's involved. Just don't forget to do your reducing. 36 divided by 4. 4 goes in 9 times. And whether you call it 9 or 9 over 1, it's the exact same thing. They both just mean 9. All right. Why don't you try that third one real quick? I'll give you a second to do it, and then I'll come in behind you. Oh. Okay. To continue here, if you tried that third one, I was going to show you an extra little shortcut. I don't want to confuse you, so I'll show it to you, and if this third one doesn't make sense, don't worry about it. Okay, we can start by going right across here. 18 times 5, which is 50, it's 90. And then we just move the 6 over, and we're done. But we have a lot of reducing there to divide that 6 and that 90 with any common factors, and that seems like a lot of work to me. So maybe I could figure out a shortcut to that, and I'll show it to you right here. When we reduce, we're just trying to divide out a common factor up here on that first part, that first version of the problem. We're thinking of what goes into the 6 and the 90 and divide that out. Well, what if we just do that now? What can I divide out of a 6 and the 18? Since the 18 is going to multiply up to the top of the problem anyway in a minute, any factor that's inside that 18, I could just divide that out right now and divide anything out of the 6 and save myself time. And it turns out 6 can divide into 6, and 6 can divide into 18. And so if I do that now, 6 divided by 6, that cancels and becomes 1. 18 divided by 6 cancels and becomes 3. And so now all that's left, that 18 reduced down to a 3. 3 times 5, 15. And I'm done. And I didn't have to do any of that work of dividing all the way into that 90. That's a lot of dividing work that I don't want to have to think about. So if that second version made sense, by all means, you can use that. If not, you're free to just stick with this. Just multiply whole numbers straight to the top and work with that until you're comfortable. All right. And let's talk about division real quick. 12 divided by 2. We know that one. That's easy. What if I did this? Like we just talked about on the previous slide, any number over 1, that's just the whole number. So that's the same exact thing. 12 divided by 2, or 2 over 1, exactly the same, still 6. Now, what if we did this? 12, and I took the division symbol and I rewrote it as parentheses. Remember what operation that is. Yep, multiply, good. And then also remember, right here, any fraction bar is actually division. Remember that it's also a division symbol. So what we've got going on, if you think about fraction division, what we've got going on right here is there's a division that's happening 2 times. We've got division with the division symbol, and we've got division in the fraction. And if we have a double division going on, they're going to cancel. Those 2 rounds of division within the same problem are going to cancel each other out, just like a pair of negatives cancels themselves out when you multiply or divide. So then we think, well, what's the opposite of division? If 2 divisions cancel each other out, what's going to be left over? And it turns out that it's multiplication. But we also have to deal with the division on the fraction, and the way we change that division so that both versions of division cancel is we flip that fraction, okay? And there's a name for that. Called the reciprocal, okay? Take any fraction and flip it over, it's called its reciprocal. So if I take a division problem and I rewrite the division to multiply, I rewrite that fraction and flip it, make its reciprocal. Let's see what happens if we cancel both of the divisions going on in the problem. What's 12 times 1/2? Well, we just learned on the last page, you can multiply straight to the top. 12, leave the whole number there, 2, and what's 12 over 2 equal? Equals 6. Well, hey, that's kind of cool, because that's what we got before. So it turns out we just proved that you can, boy, I'm having problems with my tool here. You can just rewrite the problem. You can get rid of the division in any fraction problem if you flip the sign, make it multiplication, and flip the fraction to cancel that division symbol as well, in a sense. And you end up with the same problem. Now, why would you want to do that? Why does it matter? Here's a real quick example. Because technically you can divide straight across. But what's 3 divided by 5? 5 doesn't go into 3, a whole number. It's going to be like 0.6 or something. And same thing here. We're going to end up with these decimal answers inside of a fraction, which is very messy, which is very difficult to simplify. So that method becomes very hard to use. Dividing becomes very complex if the numbers don't work out. So what's a really easy way to fix that? We just switch to multiplication. We flip that fraction. And now, we just learned in the last couple slides, multiplying is super easy. It goes straight across. 3 times 7, 21. 4 times 5, is 20. And that problem that looked difficult a minute ago looks really easy now. On this last page, 3/4 did not get flipped. Notice the 12 never got flipped or changed. We never made its reciprocal of like 1/12 or anything. You never touched the front value. All the work was on the second value. All right, here's a way for you to remember. Okay, if you didn't get all the details of why this process works for division, I think it's good to learn it, but you know, you can only do the best you can do. So at the very least, try to remember the method to use it. These are a couple of real popular ones that I've heard over the years. First one, keep it, change it, flip it. Okay, so we're going to keep it, keep that first value. Okay, you never touch the first value. Notice, okay, so we've got keep it, we've got change it right here. Okay, we change that division symbol to multiply, and then we've got flip it. Okay, and that's where you get the reciprocal. You flip that second fraction 3/5. Another one I've heard a lot of times: skip, don't touch that one. Flip, change this guy, and multiply. Okay, actually no, I think I have that one wrong. I'm a little embarrassed now. The flip applies to this. Skip the first guy, flip the second guy, and then multiply. Switch that to a multiplication. Okay, whichever of those makes sense, by all means use it. Okay, there is a third one I made up. I think it's better. I'm going to see if it catches on. How about, don't touch it, fool. Kill that division and spin that fraction, sucker. I think it's better. I think I'm going to patent it. I think it's going to catch on. All right, let's practice a little. I've been talking at you. You need to do some work. So, number one, you're going to copy down those problems, 1, 2, 3, 4, 5, 6. But actually, before you do that, I want you to answer this question for me. Look at these 6. Which problems require a common denominator before you can answer? Okay, this is a classic thing kids need to think about. We've got all the fraction operations here. There's add, there's subtract, there's multiply, and divide. Some of these you have to get a common denominator, rewrite your fractions. Some you don't. So right now, in your head, which of these will require a common denominator? Well, hopefully, you said number 1 does, because it's subtraction. That means we're taking away an amount of candy bar, one from another. They have to be the same size pieces for that to work. Number 4 is an addition. We're putting together pieces. They have to be the same size or you can't combine them. Number 5, another subtraction, is going to require those. 2, 3, and 6 are a multiply or divide. You don't have to worry about it with those. Those can go straight across. You can just work with them as is. Okay? So pause this video, do these 6 problems. I'm going to come back and show them to you in just a minute. Go. All right, we're back. I'm going to erase a little bit out of the way so we have room to work. Or all of it, I guess, because I'm ADD. No, OCD. All right, I need a common denominator, and I'm going to work downward like I showed you on the last video. And I'm asking myself now, what is a common factor between that 5 and that 3? What am I going to make as the new denominator? Common multiple of 5 and 3. What is a common multiple of these? Well, 5 times 3 is 15. I don't see any smaller multiple that's going to match than that, so that's what I'm going to use. And to make 15 on this side, I multiply by 3. We're going to do the same on top because we need to do that to have equivalent fractions. Over here, 3 multiplied by 5. I'm going to do the same on top. And now I've got equivalent fractions, but with a common denominator. Now the problem's ready to finish. 9 minus 5 is 4 15ths. There's the first one. Okay, number 2. That's multiplication. Oh, sweet. We can go straight across. 2 times 3 is 6. 8 times 4 is 32. Looking to reduce. All I see as the common factor I can take out here is a 2. So I'll start with that. 6 divided by 2, 3. 32 divided by 2, 16. And now there's no other common factor, so I'm done. Number 3. It's division. So I'm going to leave that first one. I'm going to rewrite it as a multiplication problem. And I've got to flip that second fraction. It's reciprocal. Once I do that, it's now the equivalent version as multiplication, which is much easier to do. And again, I can go straight across. 6 times 5, 30. 9 times 4, 36. And once again, I'm dividing out common factors. I see a 3 I can take out. I'm thinking of what divides into both. 30 divided by 3, 10. 36 divided by 3, 12. Oh, I'm not done. There's something else I can take out, and you just keep going till you're done. I can take a 2 out of both, and I end up with a 5 over a 6. Now, if you're asking right now, Mr. A, what if we just originally took out a 6 instead of one step of a 3 and one step of a 2? That's absolutely legitimate and smart of you. You can do that. The largest factor you can find and take out is going to get you to the answer quicker, but you can take multiple steps with smaller factors as well. That's fine. Either way works. Okay, 4. Again, we need that common denominator. We can't add these unless they're the same size. Now, did you guys notice when you did this, you already have the denominator you need? Kids will often miss this one. We can leave 14 as that denominator because 7 can multiply to become 14. You've only got to change that first fraction. 7 times 2 makes 14. Multiply the top. And we didn't have to multiply the other one at all. We just kept the 14. Okay? And that'll often happen. Look at your denominators and notice. That's often a problem that'll be thrown at you. One of them is just a multiple of the other. So you only need to rewrite that smaller number denominator. Okay, now they're equivalent. They're the same size. I can finish my problem. 10 and 3 is 13. Keep the denominator I had. Can't do any reducing. You're done. Okay, 5. Same exact thing. And you've got to be tired of me talking. I know I am. So we're just going to rip through this guy. 5 and 3 is 15. I think I already did that set of denominators once. Hopefully you're tracking with me. In fact, I did on number 1. I must be getting old. 3 minus 10. Now, that was on purpose. Did that throw anybody? 3 minus 10. Can we do that? We sure can, because we've got integer skills now. You apply your integer skills on here exactly the same as you would on a normal integer problem. They're just inside the fraction. 3 minus 10 is negative 7. There you go. And it's 15ths. Doesn't matter where we put the negative. Nope. We already learned that last week as well. You can write that fraction however you'd like. Doesn't matter where the negative goes. It's a negative fraction, not a specific negative number. All right, last one, 6. Super easy, straight across. 56. And again, dividing out common factors, I'll take a 2 out, which gives me a 6 and a 28. I could take another 2 out, which gives me a 3 and a 14, and that's as far as it can be reduced. I don't see any other common factors. Okay, hope you were 6 for 6. Okay, last thing, shortcut for your fractions, and yes, trust me, you want to do this. If I got this ugly thing to multiply, oh geez, 28 times 20, I think that's 560. And 15 times 12, I think that's 180. Oh my gosh, those are huge numbers. I really don't want to have to reduce that. This seems like a terrible, terrible thing. If we can find an easier way to do this, let's do that. Since we know that in a minute, all of the values on the top are going to be multiplied together. So any factors that are inside of 20 or 28, they're all going to be multiplied together anyway in a minute. Any factors that are inside the 15 and the 12 are all going to get multiplied together in a minute anyway. So rather than start dividing out 2s and 5s and 3s, whatever I can find, what if we just do it now? Anything on bottom, I can divide out with anything on top. For instance, the 15, I can divide a 5 out of that right now, and a 5 out of the 20. So if I divide that out, 15 divided by 5 is 3, 20 divided by 5 is 4. I got rid of factors. And that's good because now the multiplying I do is much smaller. Life's going to be much easier in a minute. Okay? And you just keep looking. Anything on top with anything on bottom, when you're multiplying, you can cancel, but it's only when you multiply. Let's pick something else. How about 28 and 12? I can take a 4 out of there. Here we go. So 28 divided by 4 is a 7. 12 divided by 4 is a 3. So now what's left on top is a 7 and a 4, and on bottom is a 3 and a 3. No more common factors, so I'm ready to finish. So now I can multiply the 7 and the 4, 28. The 3 and the 3 that were left over is 9, and there's no common factors. So that's as reduced as it'll go, and I'm done. I didn't have any giant numbers to deal with there. Much simpler. Okay, number 2. Now, it's a division symbol. That's really important to notice. We can't do what we just did on number 1. That's only for multiplication problems. Oh, what's that, you say? This is a multiplication problem when you rewrite it? That was great thinking. Good thinking, guys. So if I rewrite it, remember, keep it, change it, flip it, or skip, flip, and multiply, whatever makes more sense. Keep the first fraction intact, rewrite the second one, and then you can make it multiplication. Now that it's rewritten, you can do what you're going to do up there. So like 12 and 4, I'm going to shortcut the way I wrote the first problem. I'm going to divide a 3 out of these guys. 12 divided by 3 is 4. Or excuse me, I'll divide a 4 out of each of these guys. 12 divided by 4 is 3. That looks terrible. There we go. 12 divided by 4 is 3. 4 divided by 4 is 1. So I just divided a common 4 out of those two numbers. And I'll keep looking. Here I could divide a 2 out of the 8 and the 6. A 2 dividing into the 8 makes 4. A 2 dividing into the 6 makes 3. And again, I'm now down to no more common factors. 3 times 3, 9. 4 times 1 is 4. And I'm done. Anytime you're multiplying fractions, you're allowed to reduce and cancel out any factor on top with any factor on bottom, because they're all going to be together in a minute anyway. You try it. There's 2 practice problems for you, and you're done. Go. All right, let's see if you got the idea. The 12 and the 9, I can divide out a 3. So 12 divided by 3 is 4. 9 divided by 3 is 3. And I'll write it in on this one again so you can see what I'm doing. Okay? Now let's look at what else. And by the way, notice I can also do that top to bottom. Okay? So on this one, I'm going to divide a 2 out of the 18 and a 2 out of the 4. So you can also go straight up and down on these. Anything on top with anything on bottom. 18 divided by 2 is 9. 4 divided by 2 is 2. And then we just keep going. Let's pick a new color. How about I divide the 3 out of that 9. We're all the way down to a 3. A 3 out of the 6 over here. And we've got a 2. And in the end, that's all we've got left. 3 times 3 on the bottom makes 9. 2 times 2 on the top makes 4. All the reducing is done and we're finished. Okay, number 2, remember, you've got to rewrite it first. It has to be a multiplication problem. Keep the first one, change it to multiply, flip the second one, and then we'll do the fast version on this. It's as simple as a 16 can divide into both of these. 16 goes into itself once, into 32 twice. 3 goes into itself once. 3 goes into 12 4 times. 2 goes into itself once. 2 goes into 4 2 times. And all I'm left with is 1 times 1 on the top, 1 times 2 on the bottom. And wow, look how simple that got. All right, guys. Let me know if you have questions. Do the practice problems.